So yeah, Gami from Timeplus, streaming first analytics platform, and in this talk we're also adding some coffee elements so that you can compare different options. Okay. So first off, let's talk about the lab data, right? So this is a random report I got from the internet. It is very clear that there's a lot of data generated now and in the future, and at least 1/3 of the data is for the real-time purpose. But today, there's only about 1% of data is being analyzed, or no matter using code or using SQL. So there's a lot of potential. We can better understanding what's going on by figure out what's data in different message buses. And Kafka, Pulsar, Redpanda, there's many other there's many streaming message bus for you to store and transfer data. And it is very common that is you use SQL for big data query, right? So, but the idea we want to present in this talk that is you also should using SQL to query the live data. Why? Because it is very reliable for you to using a SQL engine, not try to build your own program by yourself. Otherwise, you might have to handle a lot of memory management, concurrency stuff. But using a robust SQL engine give you a solid foundation for you to do mission critical jobs. And also it can be very fast because the database is implemented by experts with very good understanding about performance, algorithm, data structure. So in many cases, using a SQL engine to query live data will be even faster than if you query using vanilla API from the message bus. And also it will be easier to use, right? So even a kid can write SQL to query data in MySQL, in Postgres, even Hadoop, right? So you can imagine that is if you choose the right SQL tool, you can also use in SQL easily to query whatever data in Redpanda, in Pulsar, in Nets, in MQTT. I even invite an intern to write a SQL to query to build a dashboard, and this can be easily done in a few days. And it's all very powerful, right? So if you're using the low-level API to query, to get data from the message from the topic, you might have to handle, you can easily do some basic stuff like filtering or flat transformations. But if you need to do powerful data joining or complex event processing, it requires a lot of state management, a lot of algorithm. But SQL is a very good way for you to express those logic. You can do very powerful multi-stream joining. You can have very multiple CT or subqueries, and present some complex event processing or even machine learning. So all those achievable using SQL. And also the best part is that SQL is a descriptive language. So you tell the system what you want instead of what you want to do one by one, how to do it. So the SQL engine is able to have some query analyzer or query optimizer for you to capture your initial intention using SQL and try to convert it in the most efficient way and put into the database engine so that you just showing your kind of requirements, but the SQL engine will making sure it will use the most efficient way to get the result for you. And here's some sample use cases our team have implemented recently. So you can check the link Timeplus in the Timeplus doc and in the showcase part. So there's many different industrials we can apply real-time analysis using SQL. No matter in the fintech area, even some of our clients using our technology to do real-time pricing or post-trading analysis. Some IoT customers to monitor their feet on the road or the trucks, or monitor thousands of wells in the sites, which need some edge computing and consolidated data back to the central data center or micro data center. So including the customer engagement, social listening, or security. So as long as you have fresh data, those data can be analyzed in a better way using SQL and trigger the alert, build the dashboard, and give you a better foundation to make the right decision. And so, yes, there's a lot of, but go back to the coffee analogy, that is, there's dozens or even hundreds of ways to make coffees. And yeah, maybe there's a similar different ways to query Kafka or Pulsar or Kinesis data using SQL. And this is a diagram with some logos grouped by whether it's a streaming processor, whether it's a streaming database or a real-time database. And so we only list the open source tools because this is an open source analytics conference. So we are going to go over them quickly and group by language. I know programming language may not be the most critical thing to the first factor to consider, but it means something in some way. So let's go over Java-based system to query data, query live data in SQL. And the first one, of course, is Flink, right? And Flink, this is my kind of impression for how Flink is. So it is almost a de facto standard to apply streaming processing on real time, but with a lot of effort and some learning. So it's just like this fancy machine. It is very complex, but it can, if you have the right skill, have a lot of time, you put the money and effort in, and you can come up with a good result. So for people who are familiar with Flink, so you know that they have multiple layers, and they provide both Java API and a SQL API. So there's some examples how you can get data from Kafka and query them just using SQL, even apply some join, right? And also I put a quick note. It's not really kind of a very official note. I just based on our team's experience, because many of our members in Timeplus also use Flink a lot. So Flink has great community for sure. And regarding the low latency and the streaming, it is very powerful. But for example, we from Timeplus, we build even more performance and low latency system. So Flink is very good for large scale deployment if you have hundreds of thousands of nodes, but it's not very easy to learn, and it's not real time. It's not lightweight enough. And the other common option you might get is ksqlDB. So this is, I put this image because it's a kind of a coffee, but with Coke. The reason that is if you get Kafka setup, open source Kafka setup, you can easily combine this together. You can using Kafka as the storage, but using the ksqlDB as the computer engine. And assuming all the data is in Kafka, then you can using ksqlDB to provide this SQL interface. It's similar to the Flink SQL. You can connect to the different broker, and you can write SQL to query it, even do some join. And yeah, this project has been there for quite a while, and but there are some limitations. For example, if all the data have to be in Kafka, say if your data is in some other places, such as Kinesis or Pulsar, this may not work. And also, saving all the data in Kafka, say multiple months, multiple years in Kafka, is not very practical, or can be very expensive at least, even with the tier storage. So you have to balance how many data want to be queried using ksqlDB. You cannot query a very kind of a lot of historical data in ksqlDB. And so it will also add a lot of new topics in the Kafka and some extra cost. So the other option I want to mention is Hazelcast is, again, it's also a Java-based system. One of the interesting design, they have basically memory-based computing, but they have figured out a way to leverage a cluster to share the memory. And the similar thing that is, you can have you can define all different SQLs to connect to your Kafka or Pulsar and query it. So I will. So moving next is it's more about a real-time database. So they don't really provide a streaming semantics. When I say real-time vs streaming, that is for system like Pinode. I think also share Jove his example. I'm not going to go into details. So these systems are OLAP database, but if you want to get the latest event, you have to keep a query over again. So you send the query every second, every 2 seconds. But they have very they're coming from the database side, but they are adding some real-time features on it. But compared to Flink or Proton, which will be talk about later, it's not streaming, so it's hard to do some stateful processing. And I will skip the Trino. Trino, again, it's a federation search. So it's just like the Kafka, that is that they don't really have the data. They actually push the SQL to the underlying systems to let the downstream to carry the data for you, and they provide a unified query interface for you. But they don't really have any Kafka in it, so that's why I'm using the Kafka. So moving next, we are talking about some system implemented using Timeplus, and I will hand over to Gang, our CTO, and talk about Proton, our own project first. Yeah.
Thanks, Jove. Thanks for having us. So next, I'm going to quick talk about some other options, open source options. The first one is Proton, which is a C++ based streaming processing system. This is the architecture of Proton, right? If you take a look at this architecture, actually, it's similar like the human brain, right? We talk about the streaming processing and historical storage. A quick highlight of this architecture is we have two storage, right? Streaming storage and historical storage. The streaming storage is something like a pen-only log. It's similar to Kafka, but it's internal in Proton. And the historical storage is ClearHouse. Actually, it's a OLAP column database, right? So why we have these two storage together is actually because if you do streaming data, if you do data analysis, right, if you're processing data, there are actually two ways to make it fast. The first direction is actually using streaming processing. As soon as the data comes, you do incremental stateful processing and emit processing result as soon as data comes, right? But the limitation of the streaming processing is that you cannot scan a large amount of historical data because scan data on a pen-only log usually is slow, right? The other direction is actually leverage the like a OLAP column database where you can scan a large amount of data to aggregation super fast because of the column style, right? But both of these has limitation because with historical data processing like OLAP, the real-time data, the fresh data cannot be easily handled because you need to index data, you need to merge data some way, right? So that's why actually we designed this Proton like a unified storage. It has when it's similar like the Daniel Kahneman's book, like thinking fast and slow, right? So like human brain, we have two systems. The system one is make super fast instant decision making, and system makes some logic analysis, a lot of historical data, right? So we can think that when take Proton as your brain and streaming processing is the system one, make immediately actions on your fresh data, right? And historical data is actually the system two that make analytic on large amount of historical data, right? And we actually unify this together with the SQL engine. So you don't, you actually can query this data using SQL immediately, right? So here's the sample that you can create. When talking about the query Kafka data in live, like we can create, in this case, using Proton, you actually can just create this external stream. So the external stream is actually, we don't store, there's no persistent data. So data directly come to the query engine. And we query the Kafka data, run just a SQL, and emit the result to analytical result. Of course, actually, because we have two storage, right? Actually, you can create a materials view to save those Kafka data or query result internally as a material view. So you can, so that's the case where that's actually the two systems, system 1 and system 2, actually work together, right? Both systems are good. But if you combine the two systems, it's even better because you can make decision on both the fresh data and the historical data, right? Okay, so you can think it. We do have this. So Joe showed us some of the query samples, right? We can quickly go through them. Like the first one is a streaming tail. Like it's similar. Like the car live data is just a data stream, and if you run this start from the car live data, it's actually push all the fresh data to you. As soon as there's new data from this live stream, it pushed to you. And this is the system 1, right? The historical query, actually, the system 2, actually, you can see we add a table function to this stream. Actually, we turn the streaming data to a historical snapshot. That means give me all the historical data, all what happened in the past, like do a thorough analysis on all the data, right? And there's some others like a global aggregation, continuously do aggregations, window aggregation, group data in a window. It's quite typical in stream processing, right? We also can do substream, like partition by specific car ID. And then actually we gave you a lot, we analysis all the data as a substream, all the cars at the same time. Of course, there's watermarks processing, because in the stream processing, we process a late event. And we can travel, the time travel here is actually, we seek historical data. When we processing data, we go back to a specific time offset. And the complex part is like a drawing, right? We can join the stream, you can join the stream to table. So, but that's all supported in Proton. So by all these functionalities, actually, you can query your Kafka data with so very complicated SQL functions. Also, yeah, like Jove is a coffee lover, so we make compared to coffee, like we think Proton is like something like a mocha, because it's a combination of the coffee and hot chocolate, right? It's like two systems. And we do have some coffee notes, but we can skip this part. Maybe later on, Joe will have a summary on all the coffee notes, right? So if you do want to try this function, there's actually a cloud version of Proton, which is Timeplus Cloud. So you can try all the functions here, and there's a lot of UI. It support different data sources, support the interactive queries, data lineage, and a lot of other functions. So this is something built on top of this open source Proton. Okay, so yeah, let's go to next page. And there's other options, like Proton is built on top of ClickHouse. You actually can run query your Kafka data on ClickHouse as well. But here is a sample that you create a table engine called Kafka table engine and query data on Kafka, right? You actually can do that with ClickHouse. But the difference is that the ClickHouse is like an OLAP database, only the historical one, right? It takes all your Kafka data as a table, like a snapshot. So that means it doesn't have any incremental streaming processing, right? Actually, Proton, as Proton is built on top of ClickHouse, we actually has a PR that we can contribute our stream processing part, the Kafka part, back to ClickHouse. Maybe later on you can do the same thing in ClickHouse. The other option, open source option, you can query Kafka data is actually StarRocks, right? StarRocks is built on top of open source, database. So you actually can, but with StarRocks, you actually can just ingest Kafka data instead of query Kafka data. That's the difference, right? Okay, there's some other options built on top of Rust. Let's quickly go through them. So the first one is Arroyo. So Arroyo is like a Rust-based data pipeline. You actually can create a data connect, be the connector of Kafka source, right? Then you can, this connector will connect the Kafka data and you can query it. So here's the sample that you can run query something from this other topic. Another one, which is actually you probably already noticed, is RisingWave. RisingWave is built is a Rust-based streaming database, right? If you query, like today's topic is about query live Kafka data, so that's why the RisingWave actually is an option, because it's also a stream processing. You can create a table based on the Kafka connector, and you can run the query, all the stream query. The difference compare this RisingWave and the other one, the Proton, is actually RisingWave give you the query itself is still bounded, right? But if you create the materials view, it's actually incremental processing at the background. So when you're using RisingWave, it's actually same as your other database experience when you query Kafka data.
Yeah, and the other thing I want to mention that is RisingWave still using a row-based storage, but for Timeplus or Proton, we actually leverage ClearHouse. It's a column-based, so it's a much mature and fast OLAP. Right. You can query a lot of historical data without to worry about performance.
Yeah, but I really love both the Proton and RisingWave, because with these streaming database options, it's simple, right? You just run you just create a table, run a query. That's very simple, right? This is the benefit of both. Okay, I'll give it back to Jove. Jove may make some summary on all these options, right? Which one you can see there's a lot of options to use for if you query open source data on Kafka.
Yeah, so compared to the previous logos, I add some other options. So if you go beyond open source, so if you're okay to use some cloud offering or some even non-SQL based solutions like Biwax, so there's really a lot of a way for you to query data, live data in SQL or in other tools. So I guess the key point that is this is really a good time for us to embrace this data in motion area, and also as our mission explained, that is we really want to give you a unified tool to query both historical data and the real-time data, and try choose the right tool for you with the minimal learning curve, minimal infrastructure investment to get started to implement some of the new ideas. And so each tool may have different focus. So for example, Flink is really focusing on large scale deployment, but it's based on JVM, and you might need to write some code, do some tuning. ksqlDB is based on assumption that all the data is in Kafka. Proton, we take a very ambitious goal to have focus a lot on the simplicity, as simple as a single binary, and we focus a lot on performance side and provide a unified capability for both real-time data and streaming data, and the other system like RisingWave or Biwax. So the key point that is go check different tools, and based on your team's skill set, for example, whether your team is more prefer using SQL or using Python, do you want to using on-prem deployment, want to use the cloud? What do you care a lot on the real-time side or care about the historical side? Based on your team's unique need, try those open source tools and figure out which one can work best for you. Just like coffee, that is, there's so many different coffees. You can try different ones and find which one works best for you, or even you can try different coffees in different days or even different time of the day.